Hi, my name is Yvan Boily. I'm from Mozilla. I'm going to be talking a little bit today about identity protocols and fun stuff like that. If I'm over here, can you guys still hear me? No? Okay, then I'm going to stay right here. My name is Yvan Boily. I work in our security assurance team at Mozilla, and so I've been doing a lot of work over the last year with identity protocols, primarily focused on our new identity protocol called Browser ID. So I'm going to talk a little bit about the history of identity protocols and why identity and privacy are kind of intertwined and some of the problems with using existing identity protocols online. So a little bit of terminology that I'll probably end up repeating a lot during this talk is relying party. A relying party is simply a service or a website that relies on a third-party identity provider to generate assertions and say this user who they say they are. An identity provider is just the other side of that relationship. They provide assertions to somebody else. So an example would be anything that consumes a Facebook logon to set up an account would be a relying party. Anything that and Facebook, Twitter, Google that offer services to other sites so that they can log in are identity providers. So there's a bunch of different identity protocols that people can use when they're setting up a website, different ways they can interact with services. I'm going to talk about two of the big ones, OpenID and OAuth. OpenID is a pretty convoluted protocol that is implemented and intended to function primarily within the browser. So basically the way that it works is you as a user supply through your browser or through whatever application you're using to log into a site, a URL or some token that your service provider has supplied you with that can be resolved by the application into a URL to be able to authenticate to a site. That identifier will be used by the relying party in order to establish a session with the identity authority, and from there you have the ability to go through a whole bunch of redirects and bounces back and forth in order to establish the fact that you are indeed the user by leveraging an authenticated session on the identity provider. Eventually you end up back at the relying party and have the ability to enter an authenticated session, at which point the relying party has the ability to call back to the original identity provider and verify that assertion. So there's a lot more to OpenID than that, but I could also spend the entire talk talking about how OpenID works, and that's not the point of today. So some of the concerns about how OpenID works is that even if you initiate a logon with an OpenID site, if you choose to back out after you're presented with your authentication page, your identity provider has been notified that you tried to log in. So they can build that into your profile, they can collect that data, aggregate it, figure out other stuff, and just generally figure out more about what you're doing online. In addition to that, once you actually commit to using that service provider and establish that identity, the fact that you've used that assertion will, by most OpenID consumers, be used to verify that you've actually done that, and you get an actual positive confirmation that you're using the service that's communicated, again, back to your identity provider. It's a bit of an issue because if you have a single monolithic identity provider that works in a lot of countries and is subject to a bunch of different legal jurisdictions, anybody who has the ability to force them to hand over information about you now knows what your behavioral profile is online. So it's a bit of a concern. OAuth is a little bit different. It's not designed as an identification or an identity protocol. It's designed as an authorization protocol. So the intention for this protocol was to allow a service to provide tokens to a client so that an authorized user could use a third-party service to perform operations on the primary service. So in this case, it doesn't really map directly into the identity provider and relying party role. But basically, it's a pretty straightforward process. You go through an OAuth dance and you set up access to an application. So for example, when you go into a web page that relies on Twitter, you get challenged to log in with Twitter. Then you get redirected to the Twitter site. You authorize the application, then you get bounced back, and then you have the ability to, from within your application, access different Twitter resources using the OAuth token that the Twitter service provided the client. There's a couple of different ways you can use OAuth. The two most common mechanisms for doing it are using three-legged OAuth, which is a full walk through the process. And it's typically used in a proper web-based client. There's another method which is called two-legged OAuth, where you basically just go through the first and last step and you treat the whole differentiation between an authorization server and a resource server as being the same step. So you just collapse everything. You're only doing 2 of the actual steps and just proceeding with the token that you get. That's a really radical oversimplification. Again, OAuth is one of these huge protocols that you can spend a lot of time talking about. So the biggest privacy concern with OAuth is that unlike an identity protocol where you're just looking to have somebody say, this is who I am, an OAuth token actually lets you say, this is what I'm doing, and it communicates that between each of the parties, the party that you're working with to perform an operation and the party who's actually doing something on your behalf. So if you're using a tool from a third party that lets you manage tweets, like an auto tweeter, yes?
I didn't want to interrupt your thought, but I've seen some misconception by developers that they can just use OAuth and turn off HTTPS or SSL, TLS.
Yes. So digging into a little bit more about OAuth, there's a couple of different versions with OAuth and OAuth 2.0, and in order to have OAuth be secure, especially for OAuth 2.0 where they're not using Storm Crypto, you do have to keep it over an SSL session. OAuth, neither of those 2 spiels I just gave about OAuth or OpenID is anywhere near enough to make decisions about using those 2 protocols. They're really worth reading a lot about. So basically, there's no way to, if you're using an auto tweet program to update your Twitter stream, then there's no way to isolate the fact that you're using that service and you have a relationship with that service from the relationship that you have with Twitter. There's no way to break that communication. So some of the the most important common characteristic of these 2 protocols is that when you actually use them, you're leaking information about that relationship. So every time you communicate with a third party, details are being shared, and that is all information that can be either used internally by the organization to increase the amount of knowledge they have about you, or given to third parties based on their privacy policies or contractual obligations, or given to the government, whichever government happens to ask for it and has jurisdiction over that data. So pretty significant privacy impact that a lot of people don't really consider when they're combining services. So that's basically the situation everybody ends up in. So I want to talk a little bit about 3 of the different major service providers that offer these services. So I'm going to spend a few minutes talking about Twitter, Facebook, and Google. They all have some different characteristics about what they do, and each of them has different privacy impacts depending on how users might use their services. So starting with Twitter, there's actually 2 different ways a service that consumes Twitter can function. They can use OAuth, which is, I just talked about, it's a little straightforward protocol, or they can use their own kind of half-baked Twitter solution called XAuth, where instead of using OAuth so that you don't have to share your credential with a consuming service, you share your credential with the consuming service and they give you an OAuth token anyway. So basically, instead of just authorizing an application to act on your behalf, you give them the information they need to actually access your Twitter account, and they can, according to the rules of getting access to XAuth, you're not supposed to do this, but they can basically do anything with your credential that they want to. So it's the only positive thing about this is that you can't just go and directly sign up for an XAuth token or XAuth access from Twitter. You actually have to go through an application process, and they vet those applications. To what degree, I'm not sure, but it's not even their recommended approach. They prefer people to use OAuth. One interesting aspect about Twitter is that their permission model is really simple. They don't give you access, if you have an OAuth token, you don't have access to any of that user's actual data, only their Twitter streams. Now, that said, those Twitter streams are really the information most people are interested in anyway. There's only 3 different permission levels. Read-only gives you the ability to read the entire Twitter stream, which is public unless somebody's Twitter stream is marked private anyway. Then you have read-write, which is the ability to both read and tweet on behalf of that user. And the third one, which was implemented after much consternation from users, was the segregation between the ability to read-write public tweets and the ability to send and read direct messages as well. It's an interesting distinction that they block direct messages in XAuth, but you have access to do pretty much anything you want to anyway. So it's arbitrary, but that's the design that they went with. So the big area of concern around Twitter is that when you authenticate with Twitter, it's not an actual identification. It's actually an authorization. Once you give Twitter that authorization, unless you go back and explicitly revoke it, that app can do anything they want, whether or not you're there. So if they've got that auth token stored on their server, they could do stuff in the background and do whatever they want. It's not really just saying, this is this user, and let them do stuff. Also, if you have a private Twitter stream and you just want to log into a site so you can look at their service, or you want to, for example, there's a news site in Canada that gives you the option to log in via Twitter. If you just want to read an article, all of a sudden you're giving that news site the ability to read your private Twitter stream. And finally, I find it very interesting, and I haven't found any rationale from anybody at Twitter. And there's been a little bit of discussion within the team at Mozilla about this, but we haven't figured it out just yet. The minimum access that Twitter gives to people is read-only, but there's no write-only permission. So if I want to use a retweeter app, why do I have to give them access to anything? Why can't I just say, you're allowed to tweet? So it would be interesting to see something like that, but there's no finer control than that. The advantage is that as a service, Twitter doesn't really have a whole lot more that they offer other than the ability to send and review tweets. So they have some more marketing-oriented stuff, but for the average user, that doesn't come into play. So while they can aggregate data and build a social graph based on who you follow, who you're interacting with, stuff like that, it's not to the same degree as Facebook or Google, where you're dumping basically all of your information into these gigantic repositories. So I'm actually a big fan of the low levels of permissions that they have, and the fact that you don't get the ability to configure any of the user settings via the API. So I think everybody knows who I'm about to talk about now. Before I start talking about this, none of these companies are companies that I actually have a problem with. I use all of their services for pretty much everything. I use Google Docs, I use Gmail, everybody in my family does. I always recommend their services. That said, people shouldn't use services like that unless they're actually aware and understand what the privacy implications are. So with that aside, I'm going to kind of jump in and talk a little bit about Google. Google's very interesting because they're very powerful and they're very flexible. They want everybody to use their stuff, and they're very open about it. So they support everything. You can use OAuth. You can use OAuth 1.0, which is an older version that uses strong crypto to protect things, but with the advantages you don't have to. In theory, you don't have to use SSL, but you should anyway because the tokens can be copied and used somewhere else. And then they support a hybrid model where they use OpenID to initiate the authentication process. So you log in with your Google account, and then when you're using a third-party site, then they can step up from that OpenID authorization to get OpenID identification to get an OAuth token. And they still have to go through the authorization dance where they present a dialogue that says, do you want to give Google access to this stuff? Then from there, they can go in and start performing actions on behalf of a user. And then optionally, if you don't want to get any of that stuff and have access to a person's services that Google provides, you can simply use OpenID and just use them as the ability to log into a site. An example of how OpenID is used there is if anybody's used Stack Exchange or Stack Overflow, they're one of the OpenID providers that's built right into that platform. The key issue that I have from a privacy concern here is that when you give Google access, or when you give a third-party service access to your Google account, you're presented with a dialog that says this is what the application can do with your account. The dialog doesn't necessarily give the user the full profile of how other services are interacting with that, which of the more than 40 different API endpoints that application may be interacting with other than the one that the user has specifically authorized, and it doesn't give an easy way to view all of the different interactions that user has with other components. So if you have a Gmail account and you're using something that for whatever reason has an OAuth token for Gmail, and then you're using Google+, and then they have the ability to see both of those, they can see a much more complete version of your social graph than they'd be able to if they only had access to one or the other. The other challenge is that each of those different API endpoints has radically different permissioning systems and capabilities over what kind of data that you have access to through them. So if you have an App Engine account that has that you can make API calls to do things, then you could have an application that's actually creating stuff on your App Engine account based on information that's in your email or whatever the case may be. It all depends on what permissions a user gives, and there's no easy way for a user at the point in time of authorization to simply step up and see what level of access a provider has.
It's been done that way.
Yes, but in a lot of different ways, Google has done a really good job of dumbing down technology and making it accessible to people. What they haven't been so good at is giving a full view of what people can do. And that's not to say that Google isn't trying. Like, I mean, the big area of concern that I have is the way that Google looks at stuff is kind of set up by their leaders. I mean, everybody likes to say, oh, Google's going to get better at privacy because, you know, Eric Schmidt and all of the horrible things he used to say about privacy he's not running the show completely anymore. So the problem is Eric Schmidt left, and now we have this, which shows up on every single Google service these days. That's because Google is collapsing all of your disparate user profiles and user data into a single pool of data that they're going to use to collect metrics and collect information. And it's not a negotiable decision. There's no way you can opt out of that collapsing of all of that data. Google's official response is take it or leave it. So, and the reality is, for most people, it's actually okay if they take it, unless they're doing something that, you know, you don't want other people to know about. So, and the last one is Facebook. And Facebook gets a lot of heat about privacy, and rightly so. They have access to different aspects and different and much more visibility into the interpersonal relationships that a lot of people have. From an authentication perspective, they make heavy use of OAuth 2. Virtually every API that Facebook offers is delivered through OAuth and has a fairly comprehensive permission set. So the issue that I have here with Facebook is primarily the same one as with Twitter. It's not an actual login. You're creating a relationship in the background. One thing that's really interesting is that Facebook has the ability through their permission sets to, I've lost a page here. Sorry, I'm not sure what happened there. But the permission set for Facebook gives you a lot more granular control. And of all of the API that I've looked at from any of these three providers, it's the only one that gives a user any degree of control beyond accept or deny. So with the Facebook permission model, there are a set of user and friends permissions that an app or that you can grant when you bind a service. So you have the ability to request any of these permissions when you're configuring an app, and it's actually really easy to set up. So there's a whole pile of different permissions that are all related to the user's profile on Facebook. Gives you a bunch of different information. And then they have a bunch of extended permissions, and these ones are really interesting because a user can opt out of these permissions and the app can still function. It will still allow them to proceed and go forward and configure and start using the app. So it's kind of an interesting approach and something that I'd like to see a lot more of in different permission models. It would be really interesting to see something like this, say, on my mobile phone, where I can say, yes, I want to use this app, but I don't want to give it actual GPS data or stuff like that. So that's one thing that's really cool about the Facebook API. That said, they have a lot of the same problems that other identity providers have, in that, you know, all of these different services are building these huge catalogs of data. And there's not really much we can do about that. Most of these services are things that we have started to use or use heavily because of the fact that, you know, we're active in the tech community. We want to be on top of things, learn about how all of the new things that are going on, or we have family that's spread out all over the world. We need to talk to people, stuff like that, or we run a small business and it just doesn't make sense to run our own infrastructure, so we run everything on Google Apps. So I mean, there's all of these different very, very valid reasons for using these different services, but unfortunately, there doesn't seem to be much that we can do about giving up our privacy and doing that. So one of the big challenges here too is the recommended usage for each of these is they want to see as much data from their users as possible. So they recommend that when you apply this service to the service that you're offering to your end users, that you include these like buttons and tweet buttons and share buttons or whatever the case may be on every single page in some way or another. If you have a login button, it should be on every single page, and then each time that gets loaded, if it's loaded from Facebook's site, Facebook gets to see more about how their users, whether they're logged in or not, and based on the information that they're collecting, are actually interacting with different sites on the web, not just Facebook and not just the people they interact with directly within Facebook. So one of the things that I wanted to take a look at here was we have at Mozilla some different projects. We have a privacy policy that says we're not allowed to do this. We don't host links to social media sites directly within our page. If you come to one of our websites, it shouldn't actually just leak to Twitter or Facebook that you were on our page just because we want you to have the ability to do stuff. So there's a couple of different ways that you can do this. So we have set up some of our pages, and we're moving towards getting it available on all of them, so that if you go to click on like something, instead of taking you directly to Facebook, sorry. The like thing is internal to this site. The share it button was the one I was looking for. So if you choose to share it on Twitter, it hasn't actually communicated with Twitter. It's not loading in a Twitter button. It won't do that until I actually explicitly have that user grant that I want to do that, and then it'll take me to the Twitter page. Same thing for Facebook, and you're just going to see login prompts because this is a dummy profile that doesn't actually have anything set up in it. But once you've actually given that user intent that I want to communicate with this service, we don't give away any information to those other service providers. So we have been working on a way to kind of generalize it, and it's not that original of an idea. I mean, there's some guys from BSides that did a bunch of work about this. So there's they have a jQuery plugin that handles a lot of this. So you have a 2-click interface. When you click on that Facebook icon, it'll actually load the Facebook icon and add it to the DOM at that point, only after you've signaled intent to share that data with that third party. So there's a bunch of different ways that you can accomplish this, but there's no real single generally acceptable way to do this via a library and to have services that enable the other social media things. Like some marketing teams want to have things like a tweet button that shows how many times that thing's been tweeted or how many times it's been shared, stuff like that, and pull that data through the API. So we're kind of trying to figure out and solve that problem so that we can be compatible with our marketing team without tracking and leaking our users' data all over the place. So kind of get back into the mainstream of the presentation. I forgot. At the beginning of the presentation, I forgot to tweet the slides. At the end of the presentation, I'll go through. So if you're watching and you can't see the slides, just wait a couple of minutes and you'll see them. So this link will be up there. If you want to track the work that we're doing around improving privacy of sharing and stuff like that, that's the bug number in Bugzilla. So you can go there and take a look. That'll be online and on my Twitter feed after. So one of the other things that we're trying to work on at Mozilla is overall we want to improve privacy, and we want to allow people to do stuff on different websites and different services without leaking information about what they're doing. So we've done a lot of work in the identity space, and all of that work has kind of culminated in Browser ID. Now, there's been a little bit of press because it was announced that we're rebranding Browser ID as Mozilla Persona, but the underlying technology is still called Browser ID. So I'll talk a little bit about that, and I'll show some links to the Persona stuff, and maybe talk some more about the other identity stuff that we're working on. So a little bit more terminology, because I'm going to show you another diagram. And this one I will talk about a little bit more because it's new and a lot of people don't have experience with it. In addition to the identity authorities that are common to other identity protocols, we have the concept of a primary identity authority, which is the actual identity provider. So it's Google or Facebook or some other provider that actually maintains a user profile and all these sorts of things. The second one is a secondary identity authority. And this is an identity authority that doesn't actually deliver an online profile, but it has confirmed that you are the owner of an online profile. And the way that we do that in the context of Browser ID is to use something called Verified Email Protocol, which was designed by a couple of our guys from Mozilla in our identity team, to provide a concrete mechanism by which you can use an email check to confirm that somebody actually owns an identity. And there's nothing groundbreaking about it. It's just a formalization of the workflow that everybody's already familiar with. When you go to a site, you sign up, you get an email back that says, hey, you own that email, so you must be who you claim to be. That's all it is. But it's a little bit more formal than that, and there's explanations of why we made the decisions and all that bit. And we also have the context, or the additional term of an implementation provider. Now, an implementation provider is the engine that actually provides the work that Browser ID does in order to identify a user, because we've decoupled the assertion generation process from the identification process of a user. So to explain that a little bit more, when you log in with a Browser ID page, you click on that sign-in button, and it loads the identity. It makes a call into the navigator.id.getVerifiedEmail API, which will trigger a series of calls that will load in content and get the ability to talk to an identity provider that will allow you to select which identity you're going to use and present a group of different identities so that you can select which identity you want to use on a particular site. And I'll demonstrate that in just a minute. Okay. So the way that this works, though, is the implementation provider, instead of bouncing the user agent back and forth between a relying party and an identity provider, it actually collects a little bit of information from the identity provider, verifies that the user is authenticated and has the right to act on behalf of that account, gets an assertion, and then uses that to actually build an authorization or authentication bundle that will then get transmitted back to the relying party without using or without building an actual connection between them. So there's no referrer that gets shared. There's no leakage about who's using what. It's just the identity provider knows that, hey, I was asked to verify that this person is going to do something online, and they are who they say they are. And then they pass that back to the browser. The browser handles a little bit more work and then sends an assertion and says to the relying party, here you go, this is an identity, you can use it. And the relying party has a couple of options on how they can verify that. The first one is that they can take that token and communicate back with the original identity provider and get a public key, and then they can verify that the identity assertion was generated by the provider. And that way they can say, okay, Google knows that somebody that's using a Google identifier has logged into this site from the site I'm going to show you in a minute. Is called My Favorite Beer. It's just a demo site. So they know that you've logged into that service, or that somebody from My Favorite Beer has logged in, but they don't know which user. And the traffic analysis argument kind of falls apart, because when My Favorite Beer grabs that certificate, they can cache it, and then they can use it for future checks. So in a poorly designed application, the first user after a key update might get leaked through some analysis, but a properly designed application will pull that key and store it on the production server before that actually happens. So once they verify that token, it's authenticated. If a consuming service doesn't want to go through that complexity and they're willing to leak a little bit of privacy information about their user, then they can actually bundle that assertion up and send it off to the verifier to check. That still doesn't leak the user's identifier, but the way that that check is done could potentially do that. We don't have any control about that because that is server-executed code on the part of the verifier. So in a nutshell, that's how the browser ID protocol works. And the way that we're going to demonstrate it is called My Favorite Beer. I'm always terrified about doing actual live presentations, demos during a presentation. So you can go in and you can click sign in, and it takes me to browser ID, and I've never used it before, so I'm not actually set up with anything. So what I'm going to do here is demonstrate that it's not actually using a profile on browserid.org to generate that token. I'm going to use a second service that implements a primary identity authority called ID.me, and it is a service that we have stood up to demonstrate to Google and Facebook and all of these other identity providers that you can actually do this and it works, and you can protect user privacy while still allowing them to log in as a user. So this site just generates a dummy email address, and it'll grant an assertion and allow somebody to log in. So if I set up demo user, remember the password, and now I can go into here, select to sign in, which is already open in another window.
So My Favorite Beer has your email address but doesn't know who you are beyond that, but it believes that you are legitimate based on having contacted.
So it gives you exactly. And the intention is, so the way, let me backtrack a couple of things there. So you still end up with a verified identifier for a user. So they can still track that and build profile data based on that, but the identity provider only knows that a user signed in from their service. without actually knowing specifically that it was demo user, because that assertion never ends up going to id.me. Only the identification token that was generated, that was passed back to the client, is trackable by the identity authority. And I'm not going to get too much into the mechanics of this protocol, but if you, I'll retweet it after the presentation, but we did a public security review presentation back in November about how this all works. There's tons of presentations by the people who have done this. All of this stuff has been developed in public. The source code for everything, like most of what we do at Mozilla, pretty much everything, is available on one of our various repos. So if you can't find information, if you have questions about this, feel free to send me an email after the fact, or even track me down and come and talk to me after the presentation. But basically, the whole design of this protocol is to decouple the actual authentication process, identification process, from the primary identity authority's authentication process. So you don't have that leak on use problem strictly for the purpose of identifying a user. I don't know that it'll ever be possible to come up with a similar solution for authorization, but at least in this case, we're dealing with one aspect of the problem. Basically, some things that I want to talk about in relation to this is that this isn't something that's a theoretical project. It's not something that we've been talking about, and this is something that's really neat that we can do. This is an actual available running service. It's being we currently have over 10,000 Reliant parties that have been configured and set up to use this. Now, in the context of the internet, that's actually a really tiny number. It doesn't really matter how many but we need to get some of the major identity providers on board. But this is an option. It's viable, and the way that it's working currently right now is not the way that we want it to work. Right now, it gets loaded via JavaScript, so that when My Favorite Beer actually loads some code from browserid.org. When it loads that code, it implements what's called a polyfill, which is basically a dynamically loaded replacement for an API that should be in place in the browser, and then that API can be used. Very soon, this is going to be implemented within Firefox, so the browserid.org component won't even be in place. And we're also moving forward with testing this directly for ourselves as an organization, because we're in the process of switching over so that we can have the capability to run all of our internal services that use Mozilla.com, Mozilla.org accounts to use this protocol. It's something that we have a lot of faith in, and we've done a lot of really hard work to make sure it's secure. And so, this is a really powerful way to improve the privacy of any service that's using federated identities. The really cool thing is that id.me site, if you go and download the source code for it, it's basically a blueprint for how to set up a primary identity authority. There's a very clearly documented protocol for how that all works. Basically involves exposing some well-known URLs that publish an API, and the browser ID implementation provider will query an identity to find out whether or not it has that information available before it tries to fall back to browserid.org. In a perfect world, the functionality that we provide as a secondary implementation provider would go away, so that we wouldn't be an identity broker. So that kind of caps off the whole browser ID bit. The advantage that you have from a privacy perspective with that protocol is that you start moving in the direction of decoupling the behavior that a user has from the ability to authenticate users across different services. So it provides a basic step forward to improve the security and improve the identity and privacy of users all over the world just by adopting a single new protocol for that purpose. And it's only the beginning of the efforts that we're starting to put into place in identity. As I mentioned earlier on, Mozilla Browser ID is being rebranded as Mozilla Persona, which is a collection of all of our identity-related efforts. We've got a bunch of other things that we're going to be coming out with fairly soon to show that it's possible to have strong privacy while having a fully connected world, to support doing mashups, to be able to share different services online, and have users have a single sign-on without building all that entire aggregate graph data that, depending on which part of the world you live in, can be a very serious risk to your own personal safety. So, it got cut off on my screen. So the last bit is, we have a really cool new tool that was announced at one of the at a TED Talk today called Collusion. I'll I'll put the website up here. And what this tool does is it allows you to take a look at how the different websites you're using interact with each other and share data based on tracking cookies and fun stuff like that. It's an add-on for Firefox, and it's pretty cool. So does anybody have any questions? Yeah. Yeah, this is not a replacement in any way for OAuth. Right now, I haven't done any of the research, and I'm sure somebody else is probably working on it in their head at Mozilla, because that's what they like to do there. But we have. I'm not sure what you could do to move away from something like OAuth. When you're talking about combining services and performing operations on behalf of a user, you have an implicit information leakage. It's just a fundamental problem in access control models. So. As far as it goes, I mean, this is purely an identity protocol.
Go back to that last slide so I can see the address.
Yep, I just got to actually get it up. I reused the window. Here you go. Somebody else had a question.
Is this ready to be used right now?
Yeah, absolutely. We have a bunch of different servers and services that are using it. So I can't access from this computer because I don't have everything set up properly to pull up the list. But like I said, there's over 10,000 sites that are using it. If you log into our developer site, it uses browser ID to sign in. If you log into AMO and you're not if you don't have a privileged account, if you're just a regular user, it prompts you to use browser ID. This is not something, it's not theoretical. This is actually fully in production. All of the code that we're running on our production servers is publicly available. You can take a look at everything that we're doing from this perspective. Yep. Sorry, can you repeat I'm having trouble hearing you. Okay, so the way that browser ID works is it's intended around the idea of the email address as the identifier. That doesn't necessarily mean that you have that the email address is the key to authentication. One experiment that we've kind of been tossing around, and this is just me and a couple of other guys at Mozilla, it's not an official thing, but we've been kind of tossing around the idea of creating a browser ID identity authority that is backed by a public key server. So in order to log into this identity authority, or in order to leverage this identity authority, you have to actually be able to sign a chunk of data that we present you and verify that you own the key. So, I mean, as far as actually implementing anything beyond that, you'd have to take a look at some of the compatibility issues. It's an interesting question. I haven't really thought too much about how to kind of bridge the gap, but you do have to have support for browser ID, the well-known domains, or the well-known URLs on the domain, or you have to use a secondary identity authority.
How does this interact with
Not very well. Give it a chance, though. Yeah, no, the big issue is that it is running in a regular client context in Firefox. So if you have anything that's blocking script, it breaks. And of course, as I mentioned in the review back in November, if we allow a cross-site scripting vulnerability to exist on this site, it basically pwns the entire identity process. So this is why I said this is the short-term objective right now is to actually get this as a first-class component of Firefox built into the browser, and we hope that the other browsers will follow suit because it makes it a actual proper standard. Yes. Sorry, I saw him first, so we'll come right back to you. Sorry. So the question. I'm sorry. I'm actually having a bit of difficulty hearing because I can hear the traffic behind me better than I can hear you guys. So the question was about: is this generating more passwords? Less passwords. Yes. This is the whole goal. The whole goal of federated identity is to take multiple user accounts out of the hands of users so they don't have to remember a different password for every single site. So the goal here is to establish an easy-to-use, easy-to-implement standard. It's actually, some of the feedback that some of the other developers have gotten is that it takes minutes for a new site to set up Browser ID. You don't have to go through any enrollment process with browserid.org servers. You can just download the code. We have components for WordPress, for Django. There's Ruby components for it. So you can literally just merge it in, get it running, and you're done. It's really easy to adopt. So he had a question first. He had his hand up before.
So how does this relate to when you actually want to vacate or something?
Oh.
I don't want my Facebook account to know anything about me.
So check this out. So if I go in and I sign in, and this is a feature that will be preserved when we make this a first-class browser feature as well. If I create demo user 2 because I want to have a separate identity, and sign in, and then I pop back over to log out, sign back in. I want to use a different email address. So now it's going to sign me in. So that's not the interesting part. The fact that I changed identities is no big deal. What's interesting is that the way that the browser ID Polyfill works is that it comes back and it says, hey, these are the identities you've used before. Which one do you want to use to log into this site? And this is going to be this is feature comparable to how we plan to implement this in the browser. So when you go to a browser ID enabled site or a Mozilla persona enabled site, you will select the identity that you want to use. So if Twitter supports this and Facebook supports this and Google supports this and Yahoo supports this, you'll see a catalog of all of your different accounts and click, bang, and you're done.
So as a user, this is great, preventing leakage to the vendors, but don't the vendors want to keep the leakage?
Yes?
I kind of had that.
Yes?
So how do you get the vendors to accept that leakage should be stopped?
There's a couple of different ways. Google really didn't like Do Not Track when it was released, but they just made a big announcement about that. There's a lot. It's all about market pressure, right? Shame doesn't work well. Shame, I mean, it works well, but it's not a positive interaction, right? We want Google and Twitter and pardon?
If you make it the standard, yes.
Yeah, if we get it adopted in browsers, if we get people starting to make heavy use of it, the vendors will come. They'll support it because ultimately, if people are leaving their services because they don't have the support or because they're concerned about privacy, then their value, that social graph, starts to diminish.
And of course, if one of the big,
Hang on,
one of the big information collecting entities actually also has a browser, that's kind of a problem, isn't it?
They implemented Do Not Track.
So as a developer, though, would you say it is an advantage not to have to worry about those data going to Facebook? Or did the website developers, in your experience, prefer to let that happen?
Okay, so you're asking me a question that's getting more into the overall mission of Mozilla, and from that I'm going to kind of fall back. The reason why we're concerned about this is because the only thing that Mozilla cares about is what's good for the users and good for the web. That's it. Like, we have our whole principles thing that guides, literally. I've seen some really cool business decisions made, and I come from a finance and government background where oh no, we're going to do this and we're not going to fix that because it's too expensive or blah blah blah. I've seen really cool decisions where Mozilla's we've done a big amount of work and said, hey, this isn't good for our users, so let's stop doing that, and they fix it. So it's pretty cool. Our focus is on making things better for the user, and we believe this makes things better for the user.
So as you might be implied from the name, it's really tied to the browser. How long does this live with the client applications like the desktop cache?
So there is some work underway there. We have some. That's a question that we have to take offline. It is the current implementation is tied to the browser, but much in the same way that the original implementations of OpenID and OAuth were intended to be used from a browser as well. People figured out the right ways to do it, and we hope to get better than, hey, implement a browser in your tool. But there's some discussion about that, and we do actually have people working on that. There is an LDAP extension for browser to support browser ID. So if you want to learn some more about that, feel free to drop me an email. I think I'm going to run out of time right away, but I'm going to be around and stuff. So one last thing. We also have lots of really cool open jobs. So if you're not satisfied with where you're working, come talk to me. Figure out the right people for you to talk to at Mozilla to get something new going for you. So with that, thanks for your time.